Hello students, in this class we will discuss about the superposition theorem. Superposition theorem. So the statement, look at the statement. In a linear bilateral network, so same as Thevenin's theorem, you know what is linear and what is bilateral network. The response, that means current or voltage, response means current or voltage of any branch due to the more than one source. So if a network consisting of more than one source, for example, look at the network. In this network we have two sources, V1 is one source and V2 is one source. Like this network, the response means from any branch, for any branch, this branch, this branch, this branch. So in this I am taking this is the branch, whichever we branch taken, that is RL. RL is the load branch, load is our reference. Response is equal to that response due to the two sources response is equal to the algebraic sum of individual response of the individual sources. If for this network, if we are using individual source, first case if we are using only V1 source, we will get some response. If we are using the V2 source, only V2 source, we will get this response. That response will be equal to the if two sources acting same time. That means look at here. So this is the network. In the network we have two sources, V1 source and V2 source. Due to the two sources, for any branch, this branch, this branch, this branch, I taken RL branch. The response is I am considered as a current or voltage, current of the branch or voltage of the branch. I am taking I due to V1 and V2. That means V1, V2 both are acting at RL, right. In this case, for the second case I am taking considering only one source. That means only I am using the V1 source. So that's why I am using V1 source, R1, RL, I2, and I am removing the V2 source. Removing the V2 source means always voltage, removing the sources. Removing sources is like this. Removing sources are like this. Voltage source removed by short circuit. Current source removed by open circuit. This is one of the important thing, right? Removing sources means always voltage source is removed by short circuit. That's why I am removing this source short circuit. That time for the circuit only V1 source is supply the power to the circuit, but our required thing is RL. So due to the V1 only, the current in the load is I1 I taken. That's why I1 due to the V1 only. Next, third case, I am using now V1 is removing. That means V1 is short circuited, right. Now this time I am using the V2 source. So due to the V2 source, the response in RL I taken as I2. I taken as I2. So I taken as I2. So this is I2 due to the V2 only. So now we will get three currents. First is due to two sources, second current is due to only I1 source, third current is only I2 source. So by the superposition theorem states that, look at here, the response of current or voltage of any branch due to more than one source, is I, and is equal to the algebraic sum of means plus algebraic sum of individual responses of the individual sources. For V1 source response is I1, V2 source responses is I2. Understand? This represents the superposition theorem. That means in any network, two sources acting one time, response will be equal to the individual response, sum of the individual response. This is the superposition theorem. By doing one problem, you will understand completely about the superposition theorem. So first, the question is two 10 volt source, 2 ohm, two sources are acting and we have sources. Find current I by superposition theorem and verify it. By superposition theorem we have to find out the current and we have to verify it. So first you have to find out the first case. For the solution, two sources are acting. First, two sources that means you have to use the two sources. First source is 10 volts and 2 ohms resistor. This is 1 ohm resistor and again 2 ohms resistor, 2 ohms resistor and 15 volt source. Here the load is RL, the current flowing is I. We have to find the current I, current flowing in the 1 ohm resistor due to the 10 volts voltage source and 15 volts voltage source. Two sources are acting. So in order to find out the current in this branch, I am using a simple method. That simple method is I am using the nodal analysis. So by nodal analysis, what did give a nodal analysis? How many nodes are available? Only one node. So by that node, assuming that all currents are flowing outside. All the currents are flowing outside. So just write the nodal equation. So assuming that all the currents are outside, just assumption this is, take it as I1 and I2, I3. Then by now we apply the KCL. Apply KCL at node. KCL at node. That means I1 plus I2 plus I3 is node. Then what is I1 value? Already we discussed about this. The I1 means current flowing through the 2 ohms resistor. What is the voltage of difference between two potentials? That means I1 I can write like this, that V minus 10 by 2. I1 I can write like this, V minus 10 by 2. It is I1. What is I2? Here only this is the ground, that's why this is the 0. That's why this is the 0. That means current I2 is V by 1. Next, what about this current through the 2 ohms resistor? The voltage difference is V minus 15 by 2. V minus 15 by 2 is equal to 0. One is V minus 10 by 2, another one is V by 1. That means V minus 0 by 1. Another one is V minus 15 by 2. Now you simplify this. By doing the simplification, LCM is the 2. LCM is the 2. So by doing the simplification, LCM is 2. So 2 means, so there is no change, V minus 10, but it become 2V is again V minus 15 is equals to 0. 2 multiply with 0 become 0, then 1V, 3V, 4V. 4V minus, this is minus 10 minus 15 equal to minus 25 is equals to 0. Now 4V minus 25 is equals to 0. We know that. From that we can find out V equals to 25 by 4. 25 by 4 means 4 1 ja, 4 6 ja, 0.25. V equals to 6.25 volts. V equals to 6.25 volts. Now, but what is our requirement? Our requirement is current here. From that, the current value is, I equals to V by 1. What is nodal voltage? 6.25 by 1. So the current is due to the 6.25 amperes. So finally the current due to the two sources, that means 10 volts and 15 volts, is I, that I value is 6.25. I value is 6.25. Now we will verify how the second thing, how individual sources are acting. then we will verify the superposition theorem. Okay? One source due to V1. Due to V1 means V1 is acting alone, V2 is not available. That means just modify this. V1 means only we have 10 volt source and 2 ohms resistor, 2 ohms resistor and 1 ohm resistor and 2 ohms is there, 2 ohms is there, but there it is a short circuit. Actually it is a short circuit. Understand? It is a short circuit. Why? Because we are removing the V2 source. Same principle. By applying and you have to find out the current, take it as I1 for our simplification, take it as I1. So same thing, just apply the again node analysis. Current from this node is like this. Directly I am writing here V minus current is flowing outside, current is flowing outside, current is flowing outside. Then by nodal analysis this is V minus 10 by 2 and V by 1 and V by 2 is equals to 0. By simplifying this we will get again LCM is 2, V minus 10 plus V plus V, not V here, we have 2V here, we have 2V here, because here 1 and we will get 2V here and again this is V is equals to 0. Understand? Right. So by simplifying this V, 3V, 4V, 4V minus 10 is equals to 0, V equals to 10 by 4. 10 by 4 means directly we will get 4 2 ja and 4 5 ja, that is 2.5, that is 2.5 volts. The current is equals, simply the current value is, the current from this we get V, but what about current? Current means I1, voltage by resistance, right? Voltage is 2.5 by resistance is 1, that is 2.5 amperes. So finally we are finding the current I1, that is 2.5 amperes. So I1 is completed. Same as you have to find out for V2. Now we will go for the V2. V2 means removing the first source. Removing the first source means just short circuit the first source. And the resistor is, first resistor is 2 ohms resistor, the second resistor is again 1 ohm resistor, the third resistor is 2 ohm resistor, voltage source is 15. Same thing, apply the and assume the current flowing is I2 for our simplification, current flowing is I2 for our simplification, and again apply the nodal analysis. By the nodal analysis, V by 2, V by 2, V by 1 and V minus 15 by 2 is equals to 0, minus 15 by is equals to 0, and apply the LCM. LCM is 2 here, this is V, this is 2V and this is V minus 15 equals to 0. We will simplify this expression, that is we will get like this, V plus 3V plus 4V minus 15 equal to 0. 4V minus 15 is equals to 0. So by simplifying this we will get V equals to 15 by 4. 4 3 ja 12, 4 3 ja 12, 3 is remaining here 0.75 times. So this is the 3.75 volts, 3.75 volts. So V nodal voltage is 3.75 volts. But what is our requirement? Our requirement is to find out the current I2. So current I2 is, from the current I2, the difference between voltages V minus 0 by 1. What is V? 3.75 by 1. We will get 3.75 amperes. So, finally, we are getting I2 current value is 3.75. 3.75. Now, we will verify both are same or not. Look at here. By superposition theorem, what is superposition theorem? Current I equals current response due to the two sources acting at a time, 10 volts and 15 volts source is equal to the individual sources. That is, for 10 volts I1, for 15 volts I2. So, I1 plus I2. Now, right here we have the 6.25 and for this is 2.5, for I2 this is 3.75. Look at here, 2.5 plus 3.5 is nothing but 6.25. 6.25. Why? Because 2 plus 3 is 5 and 0.5 plus 0.75, 1.25. 5 plus 1.25 is nothing but the 6.25. That means 6.25 will be equal to the 6.25. Now, the superposition theorem is verified. Superposition theorem is verified. This is the practical proof of the superposition theorem. Simple. So, now by doing the calculation, by taking the practical example, you will understand the superposition theorem. Simple. Superposition theorem is, in a network more than two sources are given, the response from the two sources is equal to the individual response of the individual sources. That is only single thing. Understand? That is about the superposition theorem statement and superposition theorem example. So, when we are discussing more problems regarding this, you will understand more about the superposition theorem. Okay? Thank you. Now, the next theorem is maximum power transfer theorem. Theorem itself, it represents maximum power transfer. So, the statement is, in a linear bilateral network, the maximum power can be transferred from source to load. From source to load. Our intention is to supply the electric power from source to load. So, our intention is, source is the generation, load is our domestic or industrial, anything. When load resistance is equal to the source internal resistance. Load resistance is equal to the source internal resistance, right. So, simply look at here, in a linear bilateral network, you know this, the maximum power can be transferred. That means, we have a source here, voltage source or current source. I take an example of voltage source. From this voltage source to this load will absorb the power from this source. But the power source to load can become maximum up to the maximum level is possible when every source has some internal resistance. Actually, this is the voltage source, so it have a series internal resistance. That name is series resistance or internal resistance. Whenever this load resistance is equal to the internal series resistance, whenever this resistance will be equal to the internal series resistance, that means maybe this can be varied, it can be varied. So, by varying the load resistance, right. So, this is the statement of the maximum power transfer theorem, right. So, generally we will understand some terms regarding the maximum power transfer theorem. In this, generally the power in any element is simply, this is the resistive element actually, in the resistive element power value equal to the load power, PL means the load power is equal to current flowing through the power, we have current I and the load resistance. So, power is formula I square RL. The other formula is voltage across the load and the current. So, to get the maximum power, the load resistance equal to source resistance. Just replace the load resistance will be source resistance. Now, PL is become PL max, maximum load power, that means that become I square into R series resistance or internal resistance. Then what is this current value? Current value will be also changed. Why it is changed? Generally the current is also, why it is changed? The reason is the circuit is become like this. Circuit is finally they become like this. This is the source, this is series resistance, again load is also become the series resistance. Now the current at maximum power equal, the current formula is voltage by resistance. Voltage is Vs, series resistance plus series resistance, right. Finally the current at maximum power equal to source resistance by 2 times of series resistance. Understand? Right. So direct, in order to get the maximum power equal to maximum current into series resistance. The current at maximum power equal to formula, you know that Vs by 2R series resistance. Then so I is square here, that's why Vs square 2RSC square into RSC. By simplifying it, we will get V square by 4 into R series resistance. Why? Because R series square is there, R series here, one square will be cancelled, then maximum power is Vs by 4R series square. Understand? This is the maximum power transferred from source to load. So in your examination, then the practical problems, so directly he will ask like this, that is a circuit is given, that circuit is a source is there and internal resistance is there, load resistance there. He is asking find out the maximum power from source to load. This is wherever the load is there, just take it as, if you given or not, just take it as the load. He is asking to find out the maximum power. So to get maximum solution is by maximum power transfer theorem, by maximum power transfer theorem. What is the theorem? The maximum power can be transferred from source to load. This is the 20 ohms and 30 ohms load resistance will be, again it become the 20 ohms. The reason is here load resistance is replaced with the internal resistance. Now in order to get the current from this load resistance, this R, in order to get the load resistance. So to find out the current, the formula for the current is voltage source is 100 by 20 plus 20. So current is 100 by 40, 2.5 times. So current is 2.5 amperes. Current is 2.5 amperes. Now the maximum power. The power, not power here, this is the maximum power. The maximum power is like this, I square into load resistance. So already we find out the current here, 2.5 square into, what is this modified load resistance is 20. Generally 2.5 into 2.5, 6.25 into 20. 6.25 is become 6.25 into 20 is become 6 2 ja 2.5 is become, generally this is 12.5 into 10, 125. Simply is nothing but the 125. How it is 125? 620 times 120, 25 into 0.25 into 20. 0.25 into 20 is become 5. 120 plus 5, 125. Right? This is the 125 watts. This is the 125 watts. So this is the procedure to do maximum power. Simply replacing internal resistance, replace the load resistance with the internal resistance, then the maximum power transferred from the source to this load, the source to this load. Some power will be taken by the 20 ohms resistor also, but our intention is source to load. Understand? This is the maximum power transfer theorem. Name itself simply you have to remind maximum power transfer. Power will be transferred from which part to which part? Generally power will be transferred from source to load, source to load. So what is the condition? When the load resistance is replaced by the source internal resistance or series resistance. This is about maximum power transfer theorem. Okay. Now we will discuss second problem regarding the maximum power transfer theorem. We will, by discussing this, we will list some more points regarding maximum power transfer theorem. The question is, this is the circuit, find out maximum power from source to load. So generally it is the voltage source, this is the source. He already mentioned RL. RL means load resistance. So this is load, and he is asking to find out the maximum power. So for that, so in order to get the power, we have to know the current from the source and with the load resistance. But load resistance is not given, but he mentioned here P max. P max means maximum power. So what is the, to get P max? To get P max, what is the condition? To get P max, load resistance will be equal to the source internal resistance. So if you know the source internal resistance, automatically that is load resistance to satisfy the P max, right? So first we have to find out the load internal resistance. So if you observe here, but the internal resistance is like this, the internal resistance is like this. So to find out the internal resistance, same as apply as follow Thevenin's, just follow the Thevenin's, because if you observe, we have 3 number of resistance, we don't know the series or internal resistance. To find out that, follow the Thevenin's. In that first, which element we require, that will be open, the remaining sources will be removed. So it is a voltage source, always voltage source is short circuited, and this is the 10 ohms resistor, and here we have 10 ohms resistor, and we have the 5 ohms resistor, and keep it open, This is the internal resistance or series resistance, internal resistance or series resistance. This is the internal resistance or series resistance. So in the Thevenin's, what we are following, just assuming some current is flowing like this. So this is seriously flowing and current will be divided here. So these two resistances are parallel. So these two resistors are parallel, so 10 parallel 10, and this circuitry will be, the circuit will be series with this resistance, equal to 10 will give the internal resistance. 10 parallel 10 and simply 5. If you do the simplification, you will get that, and with 10 is equal to internal resistance or series resistance, right? So simply we will get series resistance is 15 ohms. 15 ohms. So from that we can modify the circuit. The circuit is like this. 50 volt source is there, and we have series internal resistance with the load resistance RL. Already this is a source, and series resistance is 15 ohms. But to get maximum power, the circuit is become like this. What is the circuitry? This is a 50 volts, there is no change in the 50 volts. So this is 15 ohms, and load resistance will be become also 15 ohms. From to get maximum power, load resistance will be replaced by the internal resistance. We have internal resistance is 15 ohms, that's why 15, right? Now we will find out this is the load resistance. If we find out the current, and we will find out the maximum power also. So from this current I equal to, we can write directly, this is the 50 by 15 plus 15, 50 by 30, 0, 3 1 ja, 2 is there, 1.66 like this. It will be extended 1.666 amperes. We will get 1.66 amperes. But what is the formula for power? Not power here, maximum power. Formula is I square into load resistance. I square is what? 1.66 square into 15, 16. 1.666 become simply, so if you solve this, you will get that 1.6 into 1.6, 16 ja 196, 1.96. So it will become approximately, now it will become approximately 1.96 into 15. If we simplify this, approximately you will get 15 1 ja, 15 2 ja, almost 30, that means 29 point something, 29 point something watts, 29 point some digits. Okay, this is the P max, this is the P max. Why? 1.96 is approximately 2, that's why I write like this, right? So this is the procedure if he asking to find out the maximum power, asking to find out the maximum power. Simple thing, maximum power, whenever maximum power is coming in your mind, just simply replace load resistance with the series resistance or internal resistance. But we have 3 number of resistance, that time you follow the Thevenin's principle. By that you can find out the internal resistance. Then you will modify the circuit like this, and you can find out as usual the series, as usual maximum power, right? This is about the second problem regarding the maximum power transfer theorem. Okay, thank you.